Hello viewers, welcome back to Snap's Let's Learn Academy. In this lecture, we will discuss the operating system design and implementation. Designing the system is the process of defining the architecture of the system. Similarly, designing an operating system is designing an architecture for the operating system. The design and implementation of operating system is a complex process that involves many different disciplines. Let us discuss the problem we face while designing and implementing an operating system. The first problem in designing the operating system or any system, so we must define the goals and its specifications. At the highest level, the design of the system will be affected by the choice of hardware and the type of system which we choose. So what type of system we are going to develop and what kind of hardware we are using, or we are implementing operating system on which hardware, that also affects what type of complexity will be there for designing and implementing the operating system. So whether the hardware and the type of system is a batch processing system or time shared system or real time operating system or multi-user operating system or general purpose operating system, so what type of operating system we are implementing, so that shows the types of system. So in traditional, we develop operating system for desktop, laptop. So it is a hardware like mobile, laptop, desktop. So types of system is single user, multi-user, multitasking, real-time operating system. So what kind of type of system which we are implementing. So that shows the complexity of implementing the different disciplines in the designing and implementation of operating system. So beyond this highest design level, the requirement may be much harder to specify. So we have classified two basic groups of the requirements. The first one is the user requirements or user goals. Second one is the system requirements or system goals. So requirement may be categorized in these two groups. So user can specify some of the requirements, based on that the system can be developed. And apart from the user requirement, there is a system requirement or a system goal which specify what kind of system to be implemented on what basis. Let's understand this user requirements or user goals. So when it comes to the user desire a certain obvious properties in the system. The system should be convenient, always user prefer the system should be convenient, and that system should be easy to use and easy to learn. It should be reliable, safe and fast. Of course, these specifications are not particularly useful in the system design, since there is no general agreement on how to achieve them. But we need all these characteristics, we can say, from the user perspective. User wants the system should be implemented in very convenient way, so that user can easily use it, learn it, and it should be reliable, safe and fast. Coming to the second requirement, that is the user requirement or system requirement or system goal. From the developer's point of view, the developer always want the design should be easy to implement, easy to maintain, because reusability is also one of the characteristics of the designing and implementing the software. So hence, always the designer prefer the design which should be easy to implement, easy to maintain, easy to operate, and it should be flexible, it should be reliable. Flexible means it should take any changes which the user or the designer wants to make any changes in the system, that should be accommodatable. So that should be flexible, reliable, error free, no bugs, no errors should be there in the system while designing and implementing it. So it should be error free and it should be efficient. So these are the specifications what we have for users perspective and systems perspective. So user goal and system goal. To design and implement the operating system, some of the mechanism and policies are needed. Without the mechanism and policies, we cannot implement, we cannot design the operating system. So hence the mechanism which determines how to do something, the mechanism determines how to do something, and policy determines what will be done. Right? For example, the timer construct is a mechanism for ensuring the CPU protection. So timer is there. So timer is construct because it is a mechanism for ensuring the CPU protection. But deciding how long the timer is to be set for a particular user, that is the policy decision. That is policy. How much time has to be given for a particular user is a policy, whereas the timer construct is a mechanism which ensures the CPU protection. So that is the mechanism. How much time the CPU has to give to every user, how long the timer is set for a particular user is a policy. So what will be done? So there is a separation of policy and mechanism is important for the flexibility. Why it is? Policies are likely to change across the place over the time. In worst case, each change in the policy would require a change in underlying mechanism. A general mechanism insensitive to changes in policy would be more desirable. A change in a policy would then require redefinition of only certain parameters of the system. So therefore, a general mechanism flexible enough to work across a range of policies is preferable. For example, say a mechanism. Let me take you to the next slide. So this is the separation of the mechanism and the policy. Let's assume that this is the policy. This is the policy what we have, right? This is the mechanism. So what we are saying, the separation of policy mechanism is important for the flexibility, right? So here the separation, the both this mechanism and this policy is separated. So separation of policy and mechanism is important for flexibility. So this kind of implementation of mechanism and policy is good for the operating system and it gives us the flexibility. Whereas if both mechanism and policy are gathered together, which is not good, which is not flexible, right? Which is not good, which is not flexible. So we have to separate the mechanism and policy. as I gave the example of the timer. So timer construct is a mechanism which ensures the CPU protection. So timer is a mechanism which ensures the CPU protection, but deciding how long the timer is to set for a particular user, that is the policy. So you cannot uh, integrate both mechanism and policy together. So one user is taking entire time of the CPU, other users are waiting. That is not a flexible, that is not a good mechanism and good policy. So we can't say the operating system design and implementation is good, right? Only one user is accommodated by the CPU, others are waiting in a queue. That is not a good operating system, that is not flexible enough. So timer is a mechanism which ensures the CPU protection, how much time has to be given for each of the user, which is decided by the policy. So as per the policy, say for example round robin policy, where each CPU slice or the time quantum is distributed among the users. So timer is the mechanism, that timer is allocated, each quantum of the CPUs are allocated to the each of the user. So round robin algorithm, that is the policy. As per that policy, whichever the process enters the CPU, whichever process enters the CPU waiting for the CPU will get each slide in round robin fashion. If shortest job first policy we are implementing, or first come first serve policy we are implementing, so that will treat your user processes in different way because of the policy. The mechanism remains same, the CPU remains same, the timer remains same. So CPU time is allocated to all the processes, but it is the policy which is deciding what kind of time or how long the timer should be set for each of the user or each of the process. So this is how you can understand this mechanism and policy. Why it is important? Because of this reason, one process gets all the time of the CPU, others are idle means, so it might go to the deadlock situation. So therefore, so separation of the mechanism and policy is always good for implementation of the operating system, which provides you the more flexibility. Hope you understood this example. So this is what we have talked. Okay, assume that once an operating system is designed, okay, so once the operating system is designed, so designing part is completed, then it must be implemented, right? So once you complete your all the designing task, you must implement that operating system. So traditional operating system have been written in assembly language. Now, however, there are most of the commonly written high level languages such as C, C++ are there, because operating system are collection of many programs and written by many people over a long period of time. It is difficult to make a general statement about how they are implemented. So many people are working, so many people are writing the code and designing the system for a longer period. So it is difficult to make a general statement about how they are implemented. So early operating systems, as I said, written in assembly languages, and now the most of the operating systems are written in high level languages such as C, C++, with small amount of the system written in assembly language, but most of the components are written in high level languages. Let us understand the advantages of using the high level languages. The code can be written faster because high level language is a English kind of language, so we can write the code in English kind of language, and writing the code can be faster compared to assembly language. And it is more compact, so it provides more. uh, why it is compact means we can use many modules. Reusability things is there, so with the help of reusability we can make our program compact. It is easier to understand and debug. As I said, it is written in a high level language, means English kind of language, so therefore easier to understand also. If there are errors, so we can easily debug also. It is easy to port, so implementing on one computer and running on other computer, so that portability is also there. So it supports today's all the languages support this portability. So using high level language or implementing high level language for operating system are the same, those accrued when the language is used for application program. So as we develop application program, similar kind of development can be taken place. The code can be written much faster, and it can be portable, it can be easily understandable, it can be easily debug. We can debug easily, we can find out the errors easily. So we have the example of MS DOS, which was written in Intel 8088 assembly language. The Linux OS is mostly written in C and is available on number of different CPUs including 80x86 family, Motorola 680XO, Spark, MIPS, etc. So hope you understood this. So thank you for watching. In next video we will discuss the operating system structure. Thank you.